So hello everyone, and thank you, Kim, for the introduction, and thank you the entire codebar team for putting this together. Leading up to this, I've been looking forward to this, and it's following up the story, and it's been really amazing. So just a brief introduction. So hello, my name is Michael, and welcome to this codebar workshop. Today we're going to be talking about designing accessible and inclusive web interfaces. More importantly, we're going to be looking at how small changes in the way we write our code can make a real difference in how people experience the web. So throughout this session, we'll be walking through practical examples and fixing common accessibility issues together. And by the end, you should feel more confident identifying accessibility problems and knowing how to fix them in your project. Um, Yep. So just as I've said initially, my name is Michael, and I'm a web developer at the University of Derby and also an organizer at codebar Derby, where we run workshops to help people learn programming in a supportive environment. And I'm really passionate about accessibility and inclusive design and helping developers build interfaces that work for everyone. So if you would like to connect after the session, just feel free to reach out to me on LinkedIn. Um, yeah. So what I'm going to cover today. So basically, we'll start off with a quick introduction into accessibility, then look at some common issues developers run into. The main part of this workshop or this session will be basically hands-on exercises where we fix real accessibility problems together, and we'll use tools like Lighthouse to test our improvements and finally wrap up with key takeaways you can apply in your own project, personal project. Yes, let's dive right in. So what is accessibility? So accessibility basically means designing websites so they can be used by as many people as possible. It's not only about supporting people with permanent disabilities, although that is very important. But accessibility also helps people facing situational limitations, such as using a phone in bright light or with one hand, and it can also benefit people with temporary conditions like a broken arm or tired eyes. So in reality, when we design for accessibility, we are ultimately designing better experience for everyone. So we were talking about designing for everyone. And so exactly who are we actually designing for? Um, we're designing for people with different types of abilities and needs. These needs can fall into several categories that affect how users interact with digital content. For example, visual disabilities may affect how users see the text, images, or colors on our page. Hearing disabilities may affect how users access audio or visual video content. And things like motor or cognitive challenges may affect how our users navigate interfaces, interact with controls, or process information. So, yep. So next we'll talk about something called assistive technologies. Um, you just briefly spoken about what we're designing for. So, and we mentioned the various disabilities and various range of people. We've just talked about that. So they depend on something called the assistive technologies to actually interact with our content. So what are assistive technologies? These are tools that help people with disabilities access and interact with digital content. They allow users to navigate the websites, read information, and complete tasks independently. And a common example would be the screen readers. So this helps users, so they read out the content of a web page aloud. And other examples will be speech recognition softwares, screen magnifiers, and alternative input devices. So as developers, understanding how these tools work help us design interfaces that are useful for a wider range of people. Um, a very important bit or piece for needed for assistive technologies to function properly is the accessibility tree. So basically, this is how the browser translates the HTML we write behind the scene in the, of a page for assistive technologies to function. So it takes elements like buttons, headings, links, and images, and assign them meaningful roles and names. So as you can see on our screen, when we do this in code, for example, this is an image tag, and what does the browser do? So it translates it into two formats. One, the visual UI, and two, this is what it fits into the accessibility tree. So this image is given like a role image over here, and the name is being assigned whatever name we pop into the alternative text. So this is quite useful for those using assistive technologies because um, if they're not able to actually visualize or see the UI, they're able to, based on the technology they're using, they're able to know what this actual content means. So this is how users we cannot see the visual interface, can still understand the content and interact with the page. So now let's just quickly look at how we could access the accessibility tree. So just quickly, just do this. Um, just trying to open this up. Yep, zoom in and inspect. Zoom in. Yeah, this is too much. Yes, so if we could just, if you want to access your accessibility tree, you could just inspect your interface this way. When you open your DevTools, you could actually toggle this button over here. So basically, this is what accessibility tree looks like for this interface currently we're looking at. So what all the HTML we've written in code is being translated into this format, and this is what assistive technologies depend on. And if so, what is fed into the accessibility tree depends on how well our interfaces are being set up and the code we write and how good it is, and if we're using semantic HTML and the likes. So that's what is being fed into this point. So you can see all our elements over here. It gives it, we have the rows and this is a heading, and it tells us what the text it is. So this is how the technologists access this information. And go back. Mm, mm, yes. So next we talk about testing. How do we actually test our interfaces just to know how accessible they are? So there are several ways developers can test accessibility when building interfaces. One common method is by using the manual testing, which includes navigating the website using only a keyboard or testing using assistive technologies. We can also perform visual checks such as verifying colors, contrast, zooming the page, and making sure contrast indicators are visible. And there are also automated tools like as just you could use Lighthouse and Axe. So this could help identify common accessibility issues and guide developers on what to fix. So let's just have a look at Lighthouse, how would that work? So Lighthouse basically is just an auditing tool. So we use it to audit our web pages, audit our interfaces just to see how accessible they are. So it helps us catch common accessibility issues like color contrast, alternative text, form labels, missing form labels, and semantic structure. So things like that are easily caught using Lighthouse. So if we could just go back to our interface. So if you're using Chrome, you could access or open up your lighthouse where from the dev tools to when you click on this, so it takes us here. So if we wanted to just quickly run a report for this interface, um, we use the default mode and the device, we select desktop and the category accessibility. And when we click on this, it does something. So it basically produces a report for us as yes. So as we can see, because I'm just zoomed in too much. So that is why. Let me summarily. So we have this. So it assigns an accessibility score to us. Currently 88, which is fairly accessible, but could be, and also suggests opportunities for improvement, as you can see. So it identifies where the issues are on our layout or interface and how to, and it tells us what the actual problem is. And this guides us on what to improve to actually make our interface more accessible. Um, Yes. So as I said earlier, it gives us a score. That's like what we just saw from our report. Um, yes. So now let's talk about web content accessibility guidelines, commonly known as WCAG. Um, so these are international standards for making websites accessible. So these guidelines were developed by the W3C World Wide Web Consortium, which is the organization responsible for many of the core web standards. So the WCAG provides a set of recommendations that help ensure digital content can be used by people with different abilities. Most organizations aim to meet a standard of the double A, which is considered the practical accessibility standard. So these guidelines cover important areas such as color contrast, keyboard accessibility, clear structure, and accessible forms. So the WCAG is built around four main principles and often remembered by the acronym POUR, POUR. So perceivable in this case means when users must be able to perceive the content either by seeing it or hearing it through assistive technologies, as we've highlighted some of the technologies earlier in the session. Operable users must be able to interact with our interface, for example, by using a keyboard or other input methods. Understandable in this case, users and the content and the navigation should be clear, consistent and predictable. And lastly, robust. Our interface should work reliably across different backgrounds, devices, and assistive technologies. Um, so now, as I've just highlighted earlier, so there are various levels to the WCAG. The first level will be the level A, basic accessibility, and the second level above that will be the level double A. This is the level most organizations aim to meet, and it's often the standard requirement by laws and policies. And the level triple A represents the highest level of accessibility and includes the most advanced recommendations. So in practice, most websites and focus on achieving level double A compliance as it provides a strong balance between accessibility and practical implementation. So now some fun facts about accessibility. An interesting finding from the WebAIM Millions report is that most accessibility issues come actually from just a small number of common problems. And as you can see from our chart over here, um, low contrast is the most common issue affecting over 80% of home pages. And other frequent issues include missing alternative text for images, missing form labels, and empty links and empty buttons. So the important takeaway here is that many accessibility barriers come from mistakes that are actually quite simple to fix. And in this workshop, we'll focus on these common issues and look at practical ways developers can avoid them. So first, foremost, color contrast. Color contrast refers to the difference between the color of the text and the color of its background. If the contrast is too low, the text can become very difficult to read for many users. And this is especially challenging for people with low vision or certain types of color blindness. As developers, we should check that our color combinations meet accessibility standards. So tools like the Web Aim Contrast Checker make it easy to test and improve contrast using our designs. So we could just quickly go over to let's have a look of um, just have a look and see what it's doing. So this how the Web Aim Contrast Checker looks like. So how does this work? Basically, we have two colors here, the foreground and the background. So if we are to, and these are the values for the foreground, and this is the value for the background, is white. So this is a blue on white background. And what this does is, it does a calculation and gives us a contrast ratio. And here, the contrast ratio is 8.59 to 1. And also at the bottom here, it lets us know if this particular combination actually passes the standard AA or AAA. So in this case, this is successful and works perfectly fine because we have sufficient contrast. And as you can see over here, this text is quite readable and easy for anyone to understand and see properly. But in the case, for instance, if I were to change these values to maybe E3, E3, E2, and enter. So this is a light gray on a white background. So this contrast of 1.28 to 1. And obviously you can see over here that it clearly fails. And we can see that it's quite difficult to read this text over here. And so when designing our interfaces, we should also make sure that our color combination passes or is sufficient. And if we're not sure about it, we could always check using the color contrast over here. And so contrast checker. So as I've already highlighted over here that, as you can see on this side of the page, on the left-hand side, this is an example of a failed combination, and this, on the other hand, passes. So we can see that it's quite difficult for us to read this text because it's a light gray on white background. But on the other hand, we have the black text on the dark text on white background. So this is just basically showing us how to do this check, how we can always check to ensure that whatever colors we're using for our interfaces have enough contrast so that our users can be able to see our content on our pages. And so another important tip will be you could actually do this check in browser when doing your development. So you might not actually need to leave your interface to navigate to the contrast checker. So by going to, let me give us a quick example. So by inspecting this, isn't it? So we are able to check if this particular interface is the text on the background has sufficient contrast. As you can see from the image, this is it has sufficient contrast, 12.63 to 1. So this could be this another way we could actually do a quick check where we are developing our interfaces just to be sure that we have our text has sufficient contrast. And yep. So now one of this will be our first exercise. So we'll be looking at our interface, and this is just a fictional website of a delivery company. So we'll have, which has a lot of accessibility issues. So we'll be fixing them one by one as we go along in this workshop. Um, so, um, yep. So this is our interface, and so this zoom out into command. No. Yes, and yeah. So our hero section, obviously, as we can see, is quite difficult to read this text on this background. So what we could do, let's quickly just run the report again just to so we could buttress this point. And yep, report is running again. And yes, so this is our hero section, and we can see that Lighthouse has helped us already to identify that we're having some contrast, low contrast on our page. So say the background and the four colors do not have a sufficient contrast ratio. So clicking on this, we could go in and actually have a look, and it points to the hero section, the H2 elements, the section hero, the P tag, this section here, yeah, the same as this, and the CTA. So what we're going to be doing now will be to actually come up with a better color combination and to solve this. And so what we're going to do, so we could just use our contrast checker, like I said earlier. So what we could use a very simple color combination, maybe let's use a black on white. So this has sufficient contrast, obviously, as you can see, 21:1. So that's what we'll use to make fix this. So we'll go back to our interface. Let me zoom in a little. I'm sorry, our code editor, where the code lives. And so this is the HTML bit, and we have various style sheets that we're pulling into the um, HTML. So we'll go down to our hero section over here, and yes. So as you've spotted already that our hero section is suffering from low contrasts, and hero, the H2, the P tag over here, and the CTA. So what we're going to do, we're going to go to our CSS now to fix these issues. And we've already identified a very good combination, which is black on white. So go over to our hero section, CSS. So come over here, and the background uses this color. So what you can quickly do is you can change this to use white. So we change our background to use a white background. We change our H2 element to use black text, and our P tag to use text, and our CTA background color to use black also. Then the text within it, change the color to use yeah. So now we save, come back here, refresh. So as you can see now, obviously, this is a lot easier to look at now, and it's easier for anyone to be able to read this text and understand what this means. So just to double check that what we've done the right thing. So we could run our report again. Remember, we had these errors here, and also remember we had a score of 88. So we run this report all over again to see how we're doing now. So doing this. Yes. So this obviously has taken our scores from 88 to 92, just showing us that just by solving the color contrast issue on our interface, we're able to increase our accessibility score. And you can see over here all the warnings concerning low contrast are all gone. So we have successfully improved our interface. So this is a lot easier and better for those having low vision and suffering from one form of visual impairment or the other, because at a quick glance, they're able to understand whatever we are trying to communicate on our interface. And these buttons quite easier to look at now and understand what text is within it. So yes. Yeah. So next we talk about semantic HTML. And semantic HTML here means using the correct HTML element for the job that it was designed to do. For example, we use a button element for actions, a nav element for navigation, and a header element for the top section of a page. So these elements provide meaning to the structure of the page rather than just controlling how it looks. So browsers and assistive technologies rely on this structure, as we've seen earlier, to understand the purpose of different parts of the interface. So by using using semantic HTML, we make our websites more accessible, easier to navigate, and easier to maintain. Um, so someone might be wondering, why do we bother using semantic HTML? Where we could possibly use CSS and JavaScript to control appearance and the behavior of our elements. So one of the key reasons will be semantic HTML provides built-in meaning and accessibility for browsers and assistive technologies. Things like buttons and links naturally come with their default built-in accessibility features, which we will see in coming slides. So when we use those elements, semantic elements, we get all those features for free. And rather than having to use the wrong element and trying to build in those features manually using JavaScript or CSS, when we use the correct element, many accessibility features come automatically without any extra work. Semantic structure also makes development easier because the code is clearer and more organized. And in addition, it improves mobile layouts and helps search engines better understand the content of the page. Um, yes. So next, we'll talk about alternative text. Um, Alternative text, are for short called alt text, is it's a short description added to images in HTML. So this description explains what the image shows or the information it is meant to communicate. Um, Screen readers read this alt text aloud, so users who cannot see the image can still understand its meaning. Without alt text, users relying on assistive technologies may miss important information on the page. By adding meaningful alt text, we ensure that visual content is also accessible for non-visual users. So why is alt text important? So the alt text plays an important role in making images accessible to users who rely on screen readers. So when a screen reader encounters an image, it reads the alt text aloud to describe what the image represents. And this helps people with visual impairments understand the information that the image is communicating. So the alt text also is useful if an image fails to load. So in a case where we're having internet connection issues, or for some reasons, maybe the user decides to turn off their images. So this provides like a context or description of what image is being what image it is. So by adding the alt text. So in addition, search engines use alt text to better understand and index the images on a web page. Um, so let's look at some best practice for alt text. When writing alt text, the goal is to clearly describe the meaningful information in the image. The description should focus on what is important for understanding the content of the page. So if an image is purely decorative, yes, and does not add useful information, we can use empty alt text. So the screen readers can skip it, like as we have over here. So in a case where we have decorative images, we could add an empty alt text. So this notifies, or this lets the assistive technology know that it's purely a decorative image. And it's also good practice to avoid using phrases like image of or picture of, because screen readers already announces the element as an image. So repeating the information is quite unnecessary. And yes, so this brings us to our next exercise about, so we'll be looking at how all text for these images. Let's look at our interface and see how this is being set up and what we need to do differently to improve the accessibility of our interface as regards to these images. So quickly, let's skip these. Yeah, so we have a few images on our page over here. So let me just make this bigger. So could run a new report so that we could yes, so from our report over here, we can see that Lighthouse is flagging that our images don't have alternative attributes. As you can see, so it spotted that this is one of them, and this is another image without an alt text and this. So obviously four of them all lack alternative um, text. So could just have a look from here. Could inspect this, toggle this back. So yes, so you can see from here our images lack alternative text. And so what we could do now, go back to our interface. I'm sorry, our code editor. Let me just close this. So have and what section are we looking at? We are looking at the yes, the featured meal section. And we have this first image here without an alt text, and this one, and this one. So, and we need these images because they provide information on the kind of meal, or just gives more information to the user. So they need to have some alt text. So what we need to do, we need to add alt text over here. So what I've done, I actually put this together so it's easier for us to just short alt text. So as you can see, my examples, with, as we said earlier, we should avoid using things like my my autocomplete is getting in the way. Sorry. I want to use you. That's okay. We get you. You. Um, okay. Save. And the second image as well. We just use this. And I've just put up some few for the second image, just have this here. Stay here. Save these. And the third image. Just use this object over here. So try as much as possible to avoid using phrases like image of or picture of, because just because the screen readers already have announced that this is an image, so we don't need to actually add that to our description. So having done that, we save this and go back to our interface, and we could refresh and run our audit once more to see how we are faring over here. And see. Okay, yes. So we successfully, let's go back to this. So we can see that after we've added the alt text to the other three images, the warnings on them are all gone. So what we're left with this image right now. So, and if you can see something, I will mention something about decorative images in our slide, where the image is just there, it doesn't communicate or doesn't add any other information or context to what we are trying to explain. We add an empty alt text to the image. So, so in this case, this is more like a decorative image. So what we're going to do, we're going to go back to our code editor and um, um, so the hero, so the special offer section. Yep. So this is the image, the decorative image talking about. So what we do is that we just put an alt text for this time around, an empty one. So an empty one. So we just save. So when we save this, go back to our interface and run it again. Mm. And yes, so all warnings concerning alternative text are all gone right now. So this has also helped to increase our score. So we're currently at 98% out of 100. So we're on the right path. And you can see we've added these just alt attributes. And for these, you can see from when we inspect, we now have an alt text, which we did not have initially when we started. So likewise for the other three images. And yes, so we go back to this. Yes, so another important bit we need to talk about will be the accessible links. Um, so link text should clearly describe where the link will take the user or what action it performs. So generic phrases like click here, read more, learn more, don't provide enough information about the destination. And instead, we should use more descriptive text like read, um, read the accessibility guide, download the workshop, or view the event schedule. So this is especially important for screen reader users who often navigate pages by jumping through a list of links. And because of that, each link should make sense on its own without needing surrounding text for context. Um, so for instance, we have this a good example. We have the correct use of the correct link on the left and on the right, the incorrect one. So another bit we need to point out when we're building our links is the use of semantic HTML so that the browsers and assistive technologies understand their purpose. So the correct way to actually build a link is by using the anchor element and the href attribute. This automatically provides built-in behaviors like the keyboard accessibility, and this is also properly announced by the screen readers. And some developers might want to use a span tag or a div tag to represent for a link by building in JavaScript click handlers. But there's a problem there because they will not be recognized by the screen readers as real links. So as a result, they will need to have to build in all accessibility features manually into the link. So which is the wrong way to do it. As you can see over here, this is the right way. You use the the anchor tag with the href, and don't do this because this is the wrong way to do it. This actually makes it difficult because you have to build in all the features manually, have to work on the styling and all that. So if that's an element that already does that, why go through the stress of having to build in all those features manually yourself? So visually, we should also make sure that our links are easy to identify. So users should be able to quickly recognize which elements on the page are clickable and are interactive. Common best practice include underlining links, maintaining good contrast, and avoiding relying on colors alone. It's also important to provide a visual keyboard focus indicator so that users navigating through a using a keyboard can see where they are on the page. So these visual clues help users understand which elements are links and how they can interact with them. So um, let's go back to our interface and see what's out there. Yes. So currently we have this bit that looks like a link. Um, let's inspect it to see what's happening on the wood. So, um, so we can see that this this fake link was built using a span tag. And as we've pointed out earlier, this is the wrong way to do it. And so what we're going to do now is we go, and you might be wondering why is it having the blue color and the underline. So this was done using purely CSS. As I've said earlier, that most developers make this mistake, having to do a lot of work where we could actually have done less work using semantic HTML. So we go back to this is which section? Okay, delivery updates. Come back here. So when we uncomment, because this is what is actually making it look like a link. So we uncomment this and we save, and you see it looks purely like every other text on our page. So what we're going to do now is we're going to rebuild this link the right way. And when we go back to our HTML, close this. So close this. So delivery updates section, which is this section. So we'll look for where that is. Yeah, down here. So first and foremost, we get rid of this CSS, this class over here. Then first we change this to an anchor. Okay. And we now add page web attributes. And but for this, we'll just use the dummy link since we're not going anywhere. Just use the dummy link and we save this. And yes. Now we now have, so without doing any more or styling or JavaScript, we get first and foremost, the text automatically is blue with an underline, and we get all this for free when we use the right element. And thirdly, we can also now, it has built-in keyboard accessibility, as we will see now. Yes, so when you're on your interface, when you use the tab button on your keyboard, you can actually tab through each element. So as you can see now, we can tap to it. So users who rely on keyboard navigation can easily tap through various links on our pages. And as you can see now, our link is now keyboard accessible, and also is very visually very easy to identify on our page that this is a link. So we've also gotten that visual part of it, and we have a focus ring around it. So when we tap through our page, we could actually see that. Let me go. No, there's this. Yes, yes. So we could actually tap to it, so which is good. And but there's one more thing. Remember when we are talking about the text in our links, we should make our the text provide enough context for the users to let them know where they're heading to. And so at the moment, click here does not actually say much or give the user enough information. So we'll improve on this also by going back over here and just moving this text, all of this in here. And when we save this, yes, so now I think it's much better as the user actually reading through the link is able to know that this is where we're heading to rather than just using a generic click here. So we're successfully improved on what we had initially, and users can easily, this is better for those that rely on assistive technologies to navigate, and even users that rely on keyboard movement, keyboard controls alone to navigate our website. Um, so another important element which we have on our pages, and it's very important we point that out, and also look at best practice for that, will be accessible buttons. So buttons are used basically to trigger actions on a page, like submitting a form, opening a menu, playing a video, or adding an item to a cart. So it's important to use the correct HTML element, the button element already, because the button element already has built-in accessibility features. And this means it works with the keyboard. So using things like tab, enter, or the space on our keyboard, we're able to interact with our buttons. And if we try to create buttons using the div element or the span, we lose these built-in accessibility features, and we have to do more work to build them back in. So the simple rule here will be if something performs an action, we should use a button element for it. Um, as I've just talked about earlier, so you have um, button on the while using a div tag, and the other button using just element. What happens? What are the problems when we do what use a div for a button? What happens here is that we automatically lose the keyboard accessibility and we have to do more work to build that back in. Screen readers may not recognize it as a button, and but on the other hand, when we use the actual elements, the semantic element the semantic element button to build our buttons, we get built-in keyboard support. Screen readers recognize it automatically, and no extra accessibility work is required. Um, so now we'll go back to our interface once we just look at this. So we have um, what looks like a button here. So, and this says claim your 20% discount. And when we inspect this, we have this. So we can see that this was built using a div tag. And as I said earlier, this is not the right way to do it. And other things we're going to lose now is that first, we are going to we will lose the keyboard accessibility features as we'll see shortly. So when I'm tabbing through this interface using the tab key on my keyboard, you can see that it's automatically skipped. So it's not focusable, and it's quite difficult for those users that rely on keyboard controls to interact with our interface. So what we're going to do now is we're fixing this, using the right element for this, just simply by, so what we're going to do now, this is the special offer section. Go back to the special offer section and close all of this. Yes. So this is our button over here done with using our div tag. So we'll solve this problem by just using the button. By saving this, when we go back over here now, you can now see that we're using the button, and without making any other further modification, you discover that when we tap through, you can see now it becomes focusable. So we could actually, at this point, interact with the button using our keyboard keys, the tab, the enter, the return, and all that. So at the space. So this is what we get for free when we use the right element, as I've highlighted several times. So you can see that it's now easy for us to keyboard those that or users that depend solely on keyboard controls can now interact with our interfaces better. And so, the next topic we'll look at will be the labels, accessible labels. So labels are important because they help assistive technologies understand what a form input is for. So when a label is properly associated with an input field, screen readers can announce both the label and the input type. So when a label or a screen reader, without a label, a screen reader might simply say something like edit text blank, as you can see here. So it doesn't know what that particular input element is meant for. But in a case where we have proper label, so the assistive technology or the screen reader could read out email address, edit text. So it gives the user more context on what the input element is meant for or what text that needs to go in it. So these small additions make forms much easier for users with assistive technologies to understand and complete the form better. So as you can see over here, we have two input elements, one on the left and one on the right. So the best way to associate a label with an input field is by using the label elements together with the four attributes. So as you can see here, um, the label element with the four attributes. So, and we ensure that the value of the four attributes should match the ID of the input field, as we can see. So this is for email. So this is the four attributes, and it's linked to this input element using the ID email. And and some developers might use just placeholders inside their input element. But the challenge with using placeholders is that they are not a they're not a reliable replacement for labels, and two, when the user starts typing, the placeholders disappear. And sometimes this might not be properly announced, might not be announced properly by the assistive technology. So, yep, we'll look at the form in our interface. So as you can already see, our forms lack labels. And as you can see already, it solely depends on just placeholders, which we say disappear when we start typing. Like for instance, this is our form. And at the moment, we're just relying on placeholders. And when you start typing, you see it disappears. And this the same to this. So what we're going to do now, we're going to be attaching um, labels to each of these in our code. This is the quick orders section. So we go over here, just close this. Yeah. Okay. Yep. So this are our input elements, three of them. And so what we're going to be doing right now, as I've said earlier, the best way to associate a label with an input element will be first, we have the label, and this will be for name. And the best way to associate will be to use the for, and we gave it a name, and we attach the ID over here. and also give it a name. So save this, go back, and now we have a label attached to this input element. And there's other things we also get for free. So as I've said earlier, we are connecting this to our input element. When we click on our labels now, we automatically can focus on the input element. So this is what some of the features we get for free without additional work. So clicking on this does this. So we just go over here and we repeat the same for each of our input elements. So this will be email address. So we just use it for to go to first here and give it an email and ID suggestions. And same goes here. No. So this will be for this, and this will be for maybe accept this and save. Yes. So now we have added our labels to each of them. So by clicking on this, we're able to focus on our okay. So this is good. So but we'll do one more thing before going. So this looks a little bit funny. So what we'll do now, we can change the placeholders using examples. So we could just come over here, change the placeholder over here to use accept these as some suggestions and plain this and use streets. So now we've also changed our placeholder. So this looks a lot better and easier. So when screen reader users are now filling out our form, each of the input elements are being announced and properly, and this particular label is associated with this input element. So when users now, they now actually know what needs to be filled into each of the fields over here. Yep. So next, we'll talk about radio buttons. And so radio buttons are used when users need to select one option from a group of choices. For accessibility, it's important that these options are clearly grouped together so that users understand they belong to the same question. Providing a clear group label helps users know what the options relate to before making a selection. Without proper grouping, screen readers users may hear the options but not understand the context of the question. So by grouping the options and adding a clear label, we make forms much easier to understand, as we will see shortly. So this is an example of grouping our radio buttons together. So in this example, so it shows how we can structure radio buttons accessibly using field set and legend. The field set groups related inputs together, so assistive technologies understand they belong to the same question, and the legends act more like a question label in this case. So we're using, this is preferred contact method. So each option is wrapped in a label, which allows users to click the text as well as the radio button itself, as we've seen from previous example. This structure helps screen readers clearly announce the question and the available options, making the form easier to understand and navigate. Um, so let's see. Yep. So we'll go back to our form again. Um, yeah. So we have two radio buttons over here. So we'll think of how can we group these together and ensure that this question label is very obvious to the user that it's a question and we need to select one of these as our answers. So this is again quick other section. So go over to our interface here. So we have our radio buttons over here. Let me bring this down. Yeah. So at the moment, we're using div tags to do this, which we said earlier that the best way we could group radio buttons together, this is a radio button, and this is another one, would be to use an element called field set. So this helps us to group the radio buttons together, and this also could accept that field set. So saving this. And now we also made mention of something that we need to change this also earlier. So we're using a p tag currently. So change this to use a legend. And this also a legend. And what this does is now we have this how it looks at the moment. So this associate this question to these two options. So it's quite easier for anyone using assistive technologies like screen readers to know what the question is and the options available for them to select. So these are just little changes we could make to actually improve the user experience for users that rely on assistive technologies. And next, we'll just go over to yeah. Yep. Next, we're talking about headings. So headings play a very important role in giving structure and meaning to a web page, and they help break the content into clear structure sections, making it easier for users to understand the layout of the page. For people using screen readers, headings are especially important because they act like a navigation system. Many screen readers allow users to move quickly from one heading to another to scan the page. So by using headings correctly, we make it much easier for users to navigate and find information they need. So there are some best practices when it comes to heading. So a page should typically start with one H1, which represents the main title of the page. And from there, headings should follow a logical order, such as H2, H3, and so on. So depending on the content structure. So skipping heading levels can make the page structure confusing for assistive technologies like screen readers. We should also avoid using headings purely for visual styling and instead use them to represent the actual structure of the content. So now we'll be going over to our interface once more. Yes, so this is another section, our locations. And currently everything looks fine, but let's see what Lighthouse has to say. When we run this report, let's see what it has to say. Yes, so now Lighthouse flagged heading element. So you can see it says heading elements are not in a sequentially descending order. And it pointed out the H4 we used in this section. So in this section. So let's see what's happening under the hood. So here in this section, we have a H2, which is okay. But as we said earlier, headings should follow a sequence. So we're having H1, H2, H3. But as you can see over here, we skipped a heading level to H4. So what we're going to be doing now is that we're going to fix this so that it follows a logical order. So ideally, this should be H2, then it moves to H3, and like that. So skipping a level makes this a little bit confusing for screen reader users when they are navigating our content on the page. So we'll go back to yes, our locations. Yeah. So as you can see over here, this is first and foremost, let me just go to our, this is H2. Yeah. So we have just one H1 on this page, which is this one. So that is one. Now, when we get to this section, we have a H2. So ideally, what should come next should be a H3, but we skipped a level. And so we're going to be fixing that. So this is H3, and this also is H3. Just that we get the structure right. So after making these changes, we refresh our page and we go back to Lighthouse and we run the report once again. Yes, so now we have a score of 100% and all the warnings, accessibility warnings are all gone. So we successfully fixed majority of them. And yeah, this now uses this now H2 that now goes to H3. So we don't have the, so we're not skipping any level anymore. Um, it's so another important topic we could look at is clear language. So using clear language makes content easier for everyone to understand. It's especially important for people with cognitive disabilities who may struggle with complex wordings. So it also supports people who are reading the content in a second language. And many users also tend to scan pages quickly rather than read every word in details. So by keeping our language simple and clear, we make our content much more accessible and easier to use for a wider audience. Um, some best practice using clear language is important, as I've mentioned earlier. One good example or good practice is to avoid complex wordings or unnecessary jargons that may confuse readers. It's also useful to write numbers clearly, for example, using 5 to 7 rather than using symbols that may not be read clearly by assistive technologies. When using abbreviations, so it's best to write the full text term first so that users understand the meaning. And we could also use this abbreviation element. So this can be used to provide the full explanation of um, of an abbreviation when a user hovers over or reads the content with assistive technologies. Um, Next, we'll talk about page sections. So semantic sectioning helps elements. Semantic sectioning elements help us clearly define the structure of a web page. Um, Elements such as the header, the nav, the main, article, aside, and footer each represent a specific part of the layout. So by using these elements, we give additional meaning to the content rather than relying on a generic containers like divs. Assistive technologies like screen readers use these landmarks to understand how the page is organized, and it makes it easier for users to navigate the page and quickly find information they need. Um, this is a clear example of a page structure. So each element defines a specific region of the page. So both browsers and assistive technologies understand the layout. For instance, we know like the header over here usually contains the site title or the branding, while um, the nav, sorry, the nav element holds the main navigation links, and we also have the the main section. So this represents the primary contents of the page where the most important information lives. And finally, we have the footer over here. So footer typically includes supporting information like copyright, contact links, or additional resources. Um, so accessible data tables. So tables need proper structure. So assistive technologies like screen readers can interpret the information clearly. So when a table is built with just rows and data cells, it can be difficult for screen readers to understand the relationship between the data. As you can see in our example on the screen, with this current setup now, it could be quite difficult for anyone using an assistive technology or a screen reader to be able to understand and associate the name header to Matthew, the age to 13, and the location to London. So without headers, so users may read the values but not know which column or category they belong to. So this can make the table one confusing and difficult to navigate. But by adding proper table structure, which we will look at in the next slide, will help screen readers clearly associate each bit of data with its correct header. So now look at a better structure for tables. Accessible tables need proper structure. So assistive technologies can interpret the data correctly. So first we in our tables, we should have like a caption. So caption helps to describe what the table is about before users explore the data. And we also have the header, the TH. So the TH elements identify the headings for each column or rows, and we can also use the scope attribute. So this helps screen readers understand the relationship between the headers and the data cells. So this structure allows screen readers users to move through the table and understand exactly what data belongs to which header. Um, So we just go over to our interface once more just to look at it. So we have this table um, that shows the opening hours for the restaurant, opening times and all. So what we just do now will be to let's inspect this to see how this was built. Yep, it's the table. Yes. So as we said earlier, just if it's built this way, just data cells, and there's no way to associate day to Monday. There's no way to associate opening time to 9 a.m. and there's no way to associate the closing time to 10 p.m. for screen readers. So we're going to be making some adjustments to this layout to make it easier for which our users that are rely on assistive technologies to navigate our interface. So we're going to be, this is opening our section. So we go back to our code again and we look at, yeah, this is opening our section. So what we're going to do now is first and foremost, we come down to the table, and as we've said earlier, we use TH. So these are headers. So we make this a TH, and this one a TH, this one TH. So this lets that is technology know that this is a header. And after doing that, we add a scope to associate this heading with its corresponding data cells. It's so save this, and now we also get our this. We use this as our caption. Put it in here. Now we change this from use caption for this and this. Now, so now, yeah, we might not notice much difference from this, but what we've successfully done now is that we have, by the few changes we've made, we have been able to associate this heading with all with the text in this column, and likewise this and this. So this is will be highly beneficial or useful for those that users that rely on assistive technologies to navigate our web page, as they can now associate this heading with the content or the data underneath it. Um, yes. So another important element or components that we need on our page for um, accessibility will be the skip links. So a skip link is a simple accessibility feature built at the top of a web page, and it allows users to jump directly to the main content without navigating through everything else first. So it's useful because many pages have repeated elements like headers and navigation menus. So for users navigating with a keyboard or screen reader, going through all these links every time can be slow and frustrating. So skip links help our users or those that rely on keyboard controls to move quickly to the content they actually want to read. Um, so just go from here, just look. So could close this. Let's just look at how this is how look at an example of a skip link first. So we can just tap to our page quickly just to see if yep. Now we've successfully exposed the skip link. So what this does is it's hidden, but when we tap through our page, it becomes filled. This, and we have it. So when you clicking on this takes us to the main content of the page. Yeah, I know it might not be quite useful for this small website because we have a few number of navigation items or elements, but in a case where we have very like big websites or that have various levels of navigations, primary, secondary, so that might be quite difficult. Will I say frustrating for users that rely on keyboard navigation if they have to tap through each of these elements each time they need to use our web page or interface. So a better way or an easy way for them to skip all repeated content would be to use the skip link, and by using enter on this, so this pushes us to the main content of the page immediately. And how is this done behind in the code? So what we're doing here is we're using an anchor element here, and the href is the ID of the main content. So what happens is when we click on this skips all of this, and we jump to this section, which is the main section of our page. So this quite useful for users who rely on keyboard navigation to use our web pages. And now one more topic we talk about will be ARIA, accessible rich internet applications. So ARIA provides additional semantic information when HTML alone cannot describe complex interfaces. So it allows developers to add roles, states, and properties that help assistive technologies understand UI components. So the ARIA usage tips. So there are three key rules when using ARIA. If you can use native HTML, use it instead of ARIA. Avoid changing native semantics unnecessarily using ARIA, and ensure any ARIA control are fully keyboard accessible. And yes, so let's look at some examples of ARIA attributes. We have the ARIA label. So this provides invisible text for elements such as icons that lack text. We have the ARIA hidden, so hides elements from assistive technologies such as descriptive icons. And we also have examples like ARIA expanded and yeah. Yeah. So also we have some common area roles and examples, which are one of the roles will be so this roles helps assistive technologies understand the purpose of an element on a page. They provide additional meaning when HTML alone does not clearly describe the interface. For example, the alert role is used for urgent messages that need immediate attention from the users. The dialog role identifies modal windows or pop-ups that require interaction before returning to the page. And the navigation role defines a navigation region, although in most cases it's better to simply use the semantic nav element instead. Um, yes. So the key takeaways from our workshop today. So before we wrap up, here are a few key takeaways. Accessibility does not require complex solutions. Small deliberate changes in our code can make a huge difference. Starting with semantic HTML, it gives you accessibility almost for free. And always test your work. Use your keyboard, use Lighthouse, and try to understand how different users experience your interface. And most importantly, design for real people, not just code. So accessibility is something we should all think about as developers. Um, so thank you very much for your time.